type it in, and then it populates that to change the variable to change something else that then will change what's
Did they have a survey for the campus saying should we switch to Canvas like
Nope.
years ago?
Nope.
No, this was an administration decision. It's cheaper.
They had a survey.
Okay, so for those of you who are interested in knowing what is Canvas and how it compares to other LMSs, which stands for Learning Management Systems, you can just go to the Canvas LMS website. It's made by a company called Instructor. Okay, so just go to their website, and just look up, Canvas, and you can find out more about, Canvas. The reason that we are switching to Canvas is multiple. There are multiple reasons. One is the Canvas that we're switching to is not just any implementation of Canvas. This is called the OEI Canvas. Okay, so look up OEI as well. So OEI, which is Online Education Initiative. There we go. Okay. So the OEI is a grant project that looks into how we can help California in terms of public education, higher education in California. And OEI basically wants to unify the entire state and use one single system, both policy-wise and implementation-wise, to do online classes. So this way you can take one class here, okay, and take another class over there, take another class over there, and they're all critical considered equivalent, and because they're all online, you're no longer restricted to, oh, I have to take classes within a 5-mile radius of where I live, which is 90% of the students of ARC or any community college live within a 5-mile radius of the school. Okay, so OEI is meant to kind of break down that barrier and basically say, if you need to take an English writing class, okay, what is equivalent to our ENGWR 300, and we don't have any space here on campus, you can just take it somewhere else. Okay, you can take it at Humboldt. Okay, you can take it at any community college, and it will still count as the same class. So it's a good thing, right? But what they're doing is, if a school signs up to be a part of the OEI, which means our classes become available to all the other OEI schools and vice versa, then we cannot use any other LMSs. We have to use the Canvas system, which they have chosen as their learning management system of choice.
So you can't control your curriculum?
You can, but
If it is an OEI class that is across colleges, then you cannot control the curriculum.
So like
but we can still implement our own classes using Canvas. But the thing is, D2L has to go away. Now that makes sense because the statewide OEI Canvas, is already paid for using the grant money. So the individual colleges don't have to pay, to use it. So we're saving money in the process. But Moodle is free to begin with.
That's what I'm about to say.
So I specifically asked the OEI people and say, can I use Moodle alongside with the OEI Canvas? Because the initial objection of using any alternative LMS is we're trying to save you money. So why do you want to pay D2L when you already have Canvas available? So I said, but Moodle is free. I volunteer my own time to manage the Moodle server, and it has been running very reliably since I think the uptime is close to 2 years now.
wow. Nice.
No reboot within 2 years, and it's still running efficiently enough. So, and then the answer came back and say, no, you cannot do that either, because the idea behind the OEI Canvas is also to collect data, having one centralized interface to collect data from all of you.
New.
So your grades, how you do your homework, how you progress over time, they are collecting all that data to analyze.
I dislike that
Well, you can dislike it, and you can tell these people that you do not like it.
a lot.
Civitas is the program that is responsible to collect all that data and also to make sense out of that data and quote unquote find ways to improve programs.
Are they publicly traded?
No, Civitas is okay.
Hey, dude, they're about to control education.
We
for the
are
entire
okay.
state. They're gonna make a
So
lot
so
of
this
money.
is this is what they claim. Okay, they claim that we are the student success platform for higher education. by collecting all this data, they can find out, okay, if someone, stopped accessing the system within like 4 weeks, how would that, change the probability of that person getting a passing grade out of the class? So they can do all kinds of analysis because all the grading is done using Canvas. Your grades are collected through, Canvas, so they have all the data available to do whatever they think is
That
going to
feels like
help them.
They're not as
private
good as they
data.
think they are. They get a lot wrong in our quizzes.
That feels like private data, like.
But what makes this even more interesting is if you dig any deeper, then you will find that Civitas is a product of this particular organization, Lumina Foundation.
Like Illuminati.
Okay, so this is the Lumina Foundation, which is, so they make the product called Civitas, which it makes its way into the OEI, Canvas. But these people also have influence over the accreditation organization.
Oh dear goodness.
It's ACCJC, okay? So if you want to look up, it's ACCJC.
Where are the conflict of interests?
I'm not going to comment on that. Okay, I'm just pointing out all the connections. I am recording, that's fine.
Oh, you are, okay.
This is not a problem. I don't have any problem getting this recorded and have people to look over this because these are all facts. Okay, I'm not saying anything beyond the facts.
When you
So
stop recording, we allow you to go off the record.
go off the record.
Is Lum-
I cannot be wearing any ARC
Oh,
uniform when I do
They
that.
are a publicly traded
They're not.
company.
I don't
Let's see how much their stock is worth.
Wait,
So
they are? Which one?
Lumina
Civitas?
Lumina Foundation.
is related to Civitas,
I'm about
and
to
then
find out.
Civitas
Well, you can find out.
is
How
what
much
they
stock
use
is worth.
in the OEI Canvas system. And this is the reason why I cannot continue to use Moodle anymore. Okay? Now, I even offer to the OEI people and say, if you need the data from Moodle, I can export all that stuff to you. Okay, tell me what you need, and I can work my query, SQL query, and give you whatever you need. Nope, the answer is no. We want everybody to use OEI Canvas as one single centralized place to collect all the data. Now, the Lumina Foundation is also loosely related to the ACCJC, which is the accreditation organization in charge of accrediting all the California community colleges. Okay? Now, if you want to look up even furthermore, this thing is related to CCSF, or the City College of San Francisco, but it's not a very friendly relationship. So I'm going to draw a skull here, because they decided that the CCSF is not going to get accredited. Okay, so you guys are free to look up that part of the story. Okay, look up between ACCJC and CCSF.
What's
You know,
ACCJC again?
it's the accreditation organization for accrediting community colleges in
So if we don't get accredited, all the units are taken here in the
oops, JC.
That's what happened at the community colleges.
It's called the Accrediting Commission for Community and Junior Colleges, and it's mostly it's a part of WASC, WASC, okay, WASC, which is the Western Association of Schools and Colleges. So this is a non-profit organization who is in charge of accrediting junior colleges or community colleges. Yes?
So let me understand this. People who were at CCSF and didn't transfer, their units mean nothing?
If CCSF is not going to get accredited. Now that's a whole mess all by itself. Okay, there are a lot of organizations supporting CCSF and ask ACCJC and say, why are you not letting CCSF get accredited? The reason that they quoted, and you can find it online too, this is not something that I make up. The reason is they compensated professors a little bit too much. Now, the living standard of San Francisco is not quite the same as here. Okay, you are a Google software engineer, you're making $140,000 a year.
And you barely make it.
Yes, exactly.
You're like barely scraping by. Because I get people that are like $150,000 a year and they're broke as shit.
Yes.
Like all the time.
You go to the worst part of San Francisco, and you go buy a house. It's going to cost you easily $700,000. Okay, to get something that's in a
You
really
couldn't
bad
find
neighborhood.
The lowest price that I've seen in San Francisco is $1 million.
Oh yeah.
$700,000.
$1 million is
If you
kind of like a
$700,000
norm.
house, it's probably can just.
The lot is worth more than $700,000.
Yeah.
If the house just burns down completely or termite eats the entire thing with nothing left, it's still $700,000 just for the lot. Okay.
The cost of living out there is insane.
Okay,
It's
so
expensive.
so getting back to this picture. Okay, so CCSF got the flag of they are paying professors too much, and two, they also got the flag of they do not have sufficient administrative staff. It is not top heavy enough.
What?
They do not have enough administrators. The ratio between administrators and professors is too low. They got flagged for that. Okay, so they got a few things, a few reasons why they did not get, why the ACCJC decided not to
They probably don't
accredit.
administrators because they can't afford to pay that many administrators because they have to pay the salaries that are so
Yeah.
high that they can live within the city so they can still
Yep.
work.
But you can look it up, okay? The person that the ACCJC sent to evaluate CCSF was none other than the husband of the head of the ACCJC. It is supposed to be someone who is not affiliated with the ACCJC, to be neutral, so they don't stand on the side of the ACCJC or the college being accredited or being evaluated. But the person on that team who's leading the team turned out to be the husband of the head of the ACCJC
How
at
is
the
there no
time.
accountability?
Well, okay, you guys look it up, okay? So here's a big picture of stuff, okay? Now, there's also other pieces as well, okay? The Lumina Foundation is also closely related to Bryce Harris, our current, well, maybe he retired, I don't know for sure. But he used to be the state chancellor of community colleges. So we are talking about the state chancellor of community colleges. So are you guys starting to kind of get an idea of how this web works? Okay, and the Lumina Foundation, did you say that it was publicly traded? It's not a non-profit organization?
Lumina looked like it was, but they changed it all in December.
Okay.
If they were publicly traded, I'd be going to talk to them right now.
I do not think they are publicly traded. I think they claim to be a non-profit organization. They claim to be. I don't know how that thing works, so I'm not going to comment on things that I do not
Yeah,
know.
publicly traded
But
nonprofit.
this is what I know. Okay, so this is why when OEI Canvas becomes the campus-wide system, then it will impact Moodle and also D2L, which I don't really care.
A JSON library.
Another skull here, because once OEI Canvas becomes the standard learning management system, then Moodle is no more. Okay, they will basically have to discontinue the offering of Moodle, and I cannot implement another server on the side. They won't let me do that either. So here's a picture. So that's something for you guys to investigate, to look into. Someone can claim that I am a more or less a conspiracy theorist. That may be the case. Okay, I'm not claiming that I am or I am not.
I believe you.
It's not a conspiracy.
It's more likely that this web is all like screwed up and stuff, and that there's evil people at top than the other way around. It's more
But there are things that are hidden away that most people do not see. Okay, but once you
It's like C++.
yeah, it's kind of like C++. This is more like Java because apparently so we are the end users, right? So we go through the API, right? And then you think that you're using a processor, but it turns out there's a virtual machine here that is in charge of everything. There are layers and layers of abstraction. Since the screen recorder cannot actually see my gesture, I can do that. And abstraction is a way to hide details, right?
And you have to
And
figure out
details
how to
can be
import that
facts.
library into your,
So
It's not a conspiracy.
so there you have it. That's my
there you have it. There you have it.
there you have it.
Yes, you've done it.
Well, you're being sub-safari, man.
Yes, yes.
There you have it.
Done it.
Back there, Hey, Disney, yes, sir.
Oh man, huh?
But he has that deep voice that I don't. You know, he can go like, well, you know, that I cannot really do.
Yeah.
No, he's cool. I mean, he's really cool. Okay, so we get back to the processor. So what we'll do is we are going to make sure that we load.
You want to get the file blocked for security reasons? Hold on, I gotta do it.
Okay, so we don't have the ROM loaded yet. We can do that pretty easily.
Without that, you won't be able to do it.
Doesn't change. No,
Okay.
I can still do it.
Hold on, actually.
All right.
All right, look. Add the extension jar to the end of the file I'm giving you. Yes.
Okay, do we have all the code, all the opcodes implemented? I think we did. Yep.
Is he doing
Okay.
it? Is he running it? Is it working?
It looks like, yep, that looks like the implementation of everything. I'm gonna load it here just to double check. So load image
This is when they're clicking on the
processor opcodes.rom. Click that. Edit content. Nope, it's not here.
Actually, listen there. Yeah, it's listening for the click.
I think the reason is because I have to stop simulation and then load opcode.rom.
Put that code in there. It works.
Nope, still
What's
not there.
happening, the problem is that
Oh, it's here because there's a whole chunk of memory that is not used. So it looks like we got most, if not all, the instructions here.
yeah, and then you're gonna add that later.
Close window and save the processor file, because when you save the processor file, it also saves the content of the ROM. So that's one little thing, one little trick. If you make any changes, just reload the ROM itself and then save the processor's file itself, and the content of the ROM is saved along with the processor,
Separately from the wrong file.
separately from the ROM file. But if you want to be sure, then you can always reload the content into the ROM as well. Okay. All right. So now we can go into the actual RAM where we specify the opcode. Let's do a system-wide reset first. Okay. And then we specify the actual program in RAM, edit content, and switch over to this thing. Looks a little hard to read to me.
Or library.
So I'm going to cheat a little bit and just make it a little bit easier for myself to read by having one column for the addresses. So this way it's easier for me to identify the location. Okay, one more. There we go. And then we have another one to specify the opcode of that location. So the opcode of the location is column D. So we'll start with this empty space. Like so. And there's one more thing that we need to do, which is the second column of content. So it will be this column here. So we just have to go. Oh, we can do it like this. Easy peasy. There we go. Okay, so now we have a very condensed way of looking at the RAM locations, and I think we are ready to put it into into the RAM, which is here. There we go. Shall we give it a try?
Yes.
Okay. So we got 6F, 00, 6C, a 2, F4. Nope. Nope, I'm missing something here. I'm missing this X here. This X has to be, I think I remember what it is.
It's 2F.
Yeah, I think so. It's 2F, which is 47. Let me just double check. I'm a little bit paranoid here. Okay, 47. And then we can also look at the addresses as hexadecimal numbers, which is probably a better way to do it. Okay, so I can format it over here and just say format number. Oh, it doesn't do it in hexadecimal, does it? More formats. Custom number format. No.
You won't be able
I suppose I can do the conversion like dec to x. Is that the name of the macro? Nope. Is it 2? Nope.
That doesn't stop you from programming in the past.
Nope.
It doesn't stop you from knowing
You have the deck perhaps
Because it's not a number, I think. Oh, this is right. Okay, so we got it. There we go. Yep, 2F. Okay, I just want to be sure. Okay, 6F006C, and then I forgot about this one. It's 2F. And we got 6D, 2, 4, 6C, 1, 9C, 6C, 1, 0, F3, 6C, 1, 1, B1. Okay, this is good double checking because every time we changed from something F to 1, 0, we should start a new row in the editor. So just double checking, right? It's good to double check. Okay, 1, 1 is 6C, 2F, 7, 4. Okay, this is location 1, 4. So we have a 6C00, B4, 6C, 2A, B3, 60, 6C, 1, 9, 4, 6C, 2F. Go. So that's good. F4, 6C, 9C. Oh, did I forget something? 6C1. Yep, there you go. 0, 1. 9C. 6C again. 2A. F3. 6C. 1, 1. B1. So far, so good. 7, 3, 6D, 1, 8D, 8D, B1, and a 0 at the end. Okay, so I think we got it. Better save it first. We'll call that this is the recursion.ram because it is these are the locations in RAM. Close the window, switch back to the emulator. Okay, the moment of truth. Okay, so how do we want to do this? We can do Control T, we can do the frequency thing and just make it automatically do it. I'm gonna log something, okay? I just want to be sure if it does go bad, okay? I want to be able to trace what went wrong with this, okay? So we want to track down at least the pointers. So I want to track PC, the program counter. I want to track the microcode pointer just to make sure that I got the microcode executed correctly, and also what is going on the address bus as well as the data bus. So those are the things that I really want to track. Flags, I'm not too concerned about it. If the instructions execute correctly, I'm not too concerned about that. Okay, so those are the things that we're tracking. Now we can go ahead and execute the program. And we want to find out where the actual branch is occurring. So let's go ahead and find out. So the call is happening on this line, which is location F. Okay, so at location F, we will go into the subroutine. So far, so good. It's switching to 2C. Okay. This is 2C. Oh, this is the initialization of the variable x. Okay, so that's good. Continue. Okay, this is just loading the 1. And this is 0C. I'm just double checking where 0C is. 0C is this location, so we are storing the return address at this point. So we should see something happening on the stack, right now. It's going to store the return address. The return address is the halt instruction, so it will store a 10 as the highest location of memory space, because that's the first location that that would use to store anything on the stack. Okay, so I'm going to double check because that would be visible in the simulator. Okay, so let's see. Yep, so getting to that location, that's good. Storing it as a 10, which is the return address. And then we will do the branch very shortly, right here. So this B1 will do the branch to location 11, which is the start location of the subroutine F. Okay, so let's double check. Control T. Uh-oh, we're stuck here. So B1 is not doing what it is supposed to do. This is at location 0F. So the branch is not working because we are stuck at this location, which is a jump A. So I might have specified the wrong opcode. Let me double check the opcode. The jump instruction is, that's a B1. And I specified the B1 here. Let me check the ROM and make sure that it is also a B1. It is a B1. And we check the ROM location or these slices, and B10 is not implemented. Don't. Okay, that's okay, but this is how I debug the program. Okay, just single step until it doesn't work. Okay, but it worked up to this point. So I need to go fix the code generator first for the microcode. So we go to the downloads folder, processors. Go to opcodes and look up jmp.c. Okay, the question is JMP, oh, I know why it's doing this. Because JMP is, JMP is reusing this. Is it reusing the space of some other instruction? Okay, does that work? Yep. I know why. Super stupid mistake. The ROM file is supposed to be all.rom, not opcode.rom. Ah! Okay, operator error. Bad one too. Alright, so let's stop the simulator and I can just go ahead and load the image. And this time it's all.rom. Okay. Double check it's here, right? It's good. We will go ahead and reset the whole program. I should be able to continue from here too. Well, let's give it a try. Control T. Control T. Are we branching to the right location? Yep. So this is the return address. So it's at the halt instruction now. Okay, so that didn't work. It did not branch correctly, and then it messed around with the microcode pointer. That's why it skipped that one single microcode that would have made a jump. Okay, that's okay. I can deal with that. Load from reset first.
Wait, won't that empty the RAM?
Sorry?
Do you have the RAM saved?
Yeah, I did. So reset. And reset didn't say it did not. Okay, because I don't have the simulation turned on. There we go. So reset. Load the program back in here. Load image is recursion.ram. So everything is back here. Okay, now let's go ahead and Control T. I cannot set breakpoints. Okay, that's good. It's storing the value into there. But how can we have all kinds of junks here?
That's just their program.
Isn't anything beyond that 0000? Anything past 2F is zeros?
Should be.
Then wouldn't that just be the first empty space in your RAM?
This is
That
this is kind of odd that it has. This is. Oh no wait, this is still okay, because this is still a part of the program. The end of the program or the end of RAM is here, so we're good. Okay, false alarm. Okay.
In that field, like, in that text field, I have a picture. How do I have?
Okay, this is specifying the jump location, and this is an F3.
And
It
F3
stores-
jumps somewhere you don't want it to be. I'm not sure that that's the correct.
No, this is okay because it's what it's trying to do is storing the return address right now
In the last.
in the last location of RAM, which is where the stack quote unquote begins. Remember the stack grows down,
Yeah.
so I'm using the very last location as the first location of the stack. So this is
So it can grow back down.
yeah. So this is still working.
That's still doing it.
Okay, this one should branch to location 11 because that's where the subroutine F starts. Okay, so okay, go. Yep, that's good.
No.
Okay.
So it should decrease. It will go into the branch to decrease x by 1.
Okay.
So now it should turn into 1.
We didn't see that though.
No, it's putting it back into the register first, and then it will do the subtraction and then storing back.
Okay.
So that's just
First you
the
gotta grab it.
yeah, that's the load instruction. No, this is just the compare. Actually, by the way, this is just comparing it to 0 to see whether we need to do the recursion or whether we are returning right away.
Okay, so we're still good. We're still good.
So we are still good. Okay. It's loading the 2A, so it's reading back. And this is a subtraction. No, this is not subtraction. B is a. I think B is a branch. No. 60. That's a conditional branch. And we should not perform the conditional branch and continue with this one to subtract 1 from X. So it's loading the 1 into a register, and this is the subtraction. And after the subtraction, it will put it back into the location 2F. So we are loading the address into register A. And this is the actual store. So F4 would store the value of 1 to location 2C, I think. Yeah, 2F, sorry. So location 2F is now changed to a 1. So it decrements, and then it should continue to call the subroutine again. So this is loading a 1 into register A, and then we do a subtraction from D so that we decrease the stack pointer by 1. And then at that point, we store the return address, which is 2A. 2A is the return address. We put it into A first, and then we now store indirect into where D points to. So location FE, or 254, should now be updated to be the return address, which is 2A. So this should become 2A. There we go. And then we continue to branch into the starting point of the function itself. So we are loading 1, which is the starting point of the subroutine, and this is just a jump A, which means we continue execution from the beginning of the subroutine again, which is at 1. So this is so if we can do a BT, this would be the second invocation of F. So we got main, and then we got 1 invocation of F. This is the second invocation. This is recursive. Are we okay so far? So I'm sorry? Running on auto, but then I cannot explain stuff. Then I have to go back to YouTube and annotate in the video. Okay, so this part we know pretty much it works okay. So we should see the stack getting another item, which is also the same as the previous one because they have the same return address. So we go here, unc, to F. So now it decrements to 0, but we have one more call. Remember, we decrement X first, and then we do the call to the subroutine. So it would do another call to the subroutine, which means we will save another return address on the stack, which is the same return address as the previous one, but it would, so this location should turn into 2A. There we go. So we're saving the return address. Continue execution in the subroutine at 1-1. So that's it. This is the last invocation, which is the third one. So when we go to the stack, okay, let me just show you what I mean by that. Okay. So when we go to the stack, which is the last item here, this is the return address to main. This is the return address to the first invocation of F. This is the return address to the second invocation of F. We are now in the third invocation of F. So everything is working okay. All right. So in the third invocation of F, we still have to do the compare. We compare X to 0 first, but then it won't be greater than 0 anymore, so we should do a return. So this is the first time we actually see the return in action. Okay. So we load the address of X, we load the, we put 0 into the other register, we perform the compare, and then we load the else branch address into register A, and then we have a conditional branch. B3 is a conditional branch. If I remember correctly, this is a Z based on Z. The other one is an L. So it is 0 because the X now is 0, minus 0, 0 minus 0 is 0. So this means the B3 should actually perform the branch to location 2A. The conditional branch will jump to location 2A at this point. So Control T, Control T, Control T. Yep. So we are now at location 2A. So the conditional branch worked. Now this is kind of important because this is not something that is repetitive like the previous past several clocks. So this one is new because this is the first time we do a return. So when we do a return, we have to execute. Okay, let me switch back to the instruction first, just so that we know what kind of instruction it is executing. So we are now returning in subroutine F, and the location of this instruction opcode is 2A. So we are looking at 2A is all the way down here. This is 2A. So we are now executing the instruction to retrieve the return address from the stack, put it into register A, and then we change the stack pointer, increase it by 1, and then we will branch back to the return address, where we should continue execution. Okay, so let's continue to trace it. So it would go into the location, retrieve this byte, 2A, into a register, and it will do this is just loading a 1 into register B, and then we increase register D by 1 right here, and then this B1 is branching back to location 2A because that's our return address. So B1, so we should go back to location 2A, which is right here. So the return worked just fine. I want to see whether register D is now pointing back to location 254 or FE because it should have popped and changed. So we go to the register bank and say view register bank, and register D is in fact FE. So the stack pointer is adjusted correctly. Okay, so I'm fairly sure that the rest of this program will function correctly now because we have already exercised all the instructions that really matters. Okay. But we'll go ahead and just trace the entire thing through. Okay. So this is the second return. This is the return address from the second invocation back to the first invocation of F. Yep.
So I just want to make sure we don't have to erase those data values because
no, we do not erase.
Either A, be overwritten by something else later because the memory is no longer in use, or B, will overwrite it ourselves if we ever actually add something else to the stack.
That is correct. So basically, the stack pointer is like a bookmark. The stack pointer basically says, anything from here and up are in use. Do not mess with that.
But anything below?
Anything that is below is open. It is not used. It's not allocated. So by moving the stack pointer up and down, we are changing the boundary of the stack, like which portion is in use and which portion is not in use. So that's why you don't see anything actually quote unquote erased here, because any erasing of these particular values will take extra time. Now, having said that, if you compile your C programs with special flags from the compiler, or if you link with certain types of special library, it will do certain things to the stack. It will actually quote unquote clean it up, so that way it is actually clear whether you cleaned up the stack correctly or not. And also it will unhide certain problems of crashing, because you won't have known locations on the stack anymore. Okay, just continuing this. So now we are increasing the stack pointer by 1, and we are branching back to that location, which turns out to be 2A as well. Okay, so we're back to 2A, and this is the first invocation of F, which is also about to return. So we are going to this location. This is our return address back to main. 10 is a location in main itself, and we are going to increase the stack pointer by 1. The AD is the actual add instruction, and the B1 is the branch instruction. It will branch to location 10 because that's our return address in main. Back in main, this is the halt instruction, so we will never get out of this one. This one is quote unquote infinite. So the program does work. We have recursion. But I think this is really important, because I felt that if people understand subroutine calls but they do not understand recursion, they don't really understand subroutine calls. Because you have to understand how things are actually stored on the stack in order to say, okay, now we know how recursion works.
So if you had 2 different functions, it would be relatively similar, but instead of like a nested function, like a function would call another one, it wouldn't go back to the same point, it would just go to the next point.
It would just go back to wherever the return address is specified.
But it would still be storing incrementally in
Yes.
the stack.
Yeah, so the stack, or the end of the stack, well, okay, depending on how you look at it, this will still be growing in this direction. As you return, it will go back.
But there'll be different addresses.
Correct, it will be different addresses. You can also have a single recursive subroutine, but if you have multiple recursion points, these values can still change, because the place where you do the call is different.
Right. If you have 2 places where it recurs, it would alternate.
Correct. Essentially, this address is the address right after the call sequence of opcodes. So if you know the length of the opcode, you can just calculate it by hand. But we don't have a way to put the PC into a register in this architecture, so there's no way you can actually say, oh, just add 6 to PC and store that onto the stack. We don't have a way to specify that. So that's why I have to borrow a label to know where it is that I need to store. All right, so that took a little bit less time than I thought. I was expecting a lot more bugs with this, and I have to actually go and debug it. So other than using the wrong ROM file, which is totally embarrassing, and I took med today. Okay, did you guys notice that I'm more coherent today than usual? No, not really. I'm not saying that I'm actually coherent, just relatively speaking, I'm more coherent than usual. No? Oh, okay. Good thing it's all recorded. I can actually compare my own lecture, like when I'm not on coffee and when I'm on coffee, I can see whether it makes a difference or not. So anyway, are there any questions about this program? Are there any questions about the mechanism of calling and the mechanism of returning? Guys, okay? Is that okay? Cool. All right. Because this is really important. Okay, it is on the list of things that I need to go over for this class. Okay, so I'll show you one more thing. Last time I could not find it, so I'll do it one more time. Okay, CID 142, computer science. I know I found it once on this website. I just need to go I just need to find out where I'm supposed to go to find it, because the search engine is broken. Okay, to access FAQ or for faculty and articulation, click here. That's about, okay, has 30, okay, this is approved. To view it, visit the descriptor page. There we go. So here's the descriptor page. The categories below reflect different stages. Comments, draft, final descriptors. There we go. It's a final descriptor because it has been approved already. And this is in computer science. So we go to computer science, which only has 5 descriptors. And let's see, where are those? All right, so this is kind of important even for your other classes. I know some of you cannot read the bottom. So the first one is 112, which is Introduction to Programming Concepts and Methodology. That maps to our 360, not 300. Okay, 300 has nothing to map to. 122 is Programming Concepts and Methodology 1. I believe that one is the same as our 400, which is Object-Oriented Programming. And then the other one is 132,
That's 430.
which is 430, which is Data Structure. 142 is this one, is cisp310. And then Discrete Structure is 440.
Oh,
Yep. So those are the 5 classes that most UCs and CSUs agreed and say that yes, if a class here is using that descriptor and talk about the same topics, they will accept it as a transfer class, except for Berkeley. And I think UCLA as well. So Berkeley and UCLA are the only 2 UC campuses who do not recognize this particular agreement. Okay, so getting to one of these, okay, so getting to computer architecture and organization. So the descriptor is really just a description. I know the text is a little bit small. I can always magnify a little bit. Okay, it doesn't really wrap very well. Okay, you can see how the layout of the page was not done correctly. If I were to look at this on a mobile device, it will not show very well. Most of the pages that I do in Moodle are very mobile friendly. You can just you can read my notes, mobile, using a mobile device. Okay, so the general course description, because I want you guys to make sure that you guys know what you're supposed to learn in this class. If you want to complain to the dean and say, no, we didn't learn quite all that stuff, that's fine. The minimum number of units is 3.0. We have a lab component, and that makes it 4.0. I want it to be 5.0. And let's see, the organization and behavior of real computer systems. Okay, you got me on this one. We have a toy processor, not a real computer system, okay?
Well, we can build it. Port Linux to it.
Port Linux to it, exactly. The mapping of statements and constructs in a high-level language into sequences. I think we got that, okay? We got conditional statements, we got loops, okay? So we were able to implement all of those high-level constructs using our toy processor opcodes, okay? So we got that. Of machine instructions is studied, as well as internal representation of simple data types and structures. So simple data types will be integers, okay, signed and unsigned integers. I think we definitely beat that horse to a pulp, okay, more or less, right? And structures are actually pretty easy to do. Each individual member is the entire structure is quote unquote one chunk of memory space, and then each member is just taking up one piece of that chunk. So when you look at a member of a structure or a member of an object in C and C++, it really is just an offset from the beginning of the entire structure. Yep.
Is the memory for the members always allocated in the order that they're written in the structure?
I do not think that is guaranteed. I don't think the C++ standard guarantees that those things are sequential nor contiguous. So you can turn on certain flags of the compiler to optimize for speed. If you optimize for speed, you can allocate like 1 byte, and then another integer, and then another byte. The bytes will actually take up an entire word, whatever the natural word length is. So if you're working with a 64-bit architecture, that one single char will take up 8 bytes. Because they want to optimize the number of memory read for everything. Okay, let me just kind of explain that one because I think it is a little bit hard to see, why wasting memory space can actually be saving execution time. So I'm gonna just use a new spreadsheet. Well, I can just put it over here. Maybe not this one. Abuse this one.
You only need one operation to load it into the register.
Right. So let's say the actual natural width of your processor is 32 bytes. Okay. So each memory access can read in 32 bits at a time. Okay. And each cell is one single byte. So let me just give you a structure definition. So we have a struct. The first thing is a char. The second thing is an in32_t, which is a 4-byte thing. We'll call it y. And then the third thing is another char again. We'll call that z. Okay. So this is my structure, and we'll call this structure v. Okay. So it's a nameless struct. I'm not sure whether you can do this in C++ or not, having an object or a class that has no name itself. Can you do that in C++?
In C, maybe if you put it afterwards and type.
Yeah, in C, this is actually a valid syntax. You can specify the type. So everything from struct all the way to the end curly brace is a type specification. And then v is the name of the variable that I'm making out of it. So I cannot make another one because it has no name. But if this is all I really need to package stuff, then this is all I need. So depending on your compiler options, this is what can happen. Okay, so v.x is a single char. Okay, so I'm going to shade the char here. Okay, with something that is obvious. Okay, let's say green. And then the next one is v.y, and it takes up 4 bytes, right? So this one will take up 4 bytes like that. And let me choose a different color. Let's choose blue here. And then the last one is x.z, which is also a single byte. And we'll use yet another color.
V.y, V.z.
Oh, yeah, V, sorry. There we go. I need more medication. More, stack it up.
Until you run out of stack space.
Until I run out of stack space. We'll all run out of stack space eventually. Okay. Okay, so this is how we look at each individual member. V.x is a byte, v.y is a 32-bit integer, and then v.z is a single byte. This is what you see in C and C++. But when you organize the memory and when you allocate, then you have different ways to do it. So the wasteful way, okay, fast but wasteful. This way is basically saying, okay, v.x will allocate, okay, we'll allocate this much space. Even though we don't need all of that, we'll allocate that much. So I'm going to use this to represent how much is allocated, of which we're only using this much. Oops. Fill color. Fill with green. Okay? And then the other one, the next one is v.y. And once again, we use 4 bytes, but in this case, we use up all 4 bytes too. So we'll fill up all 4 with a blue color. And then v.z, even though it is just a single byte, I'm going to use up all 4 bytes. But only the first byte is actually in use. The other 3 bytes are completely wasted. They're not used at all. The only other purpose, or the only other thing that you can do with the other bytes, these 3 bytes, is something that's really bad. These locations can be used to mask a problem, such as the one that you encountered. So if you use the wrong type of pointer to access these locations, because these bytes are actually not in use, you can overwrite these 3 bytes, and it doesn't cause any actual problems because they're not in use. So they can help you mask problems, which is not a good thing. Okay, we want problems to surface as soon as possible and not to mask those problems, and they don't show up. Okay, but the reason why this is faster, okay, let me show you the other one. The other one is called slow but frugal. Okay, slow but frugal is going to do it like this. Okay, and in this one, I'm going to display it sideways. So v.x, v.y, and v.z. There we go. So in this particular method, v.x is going to be here. Okay, put a border around that and fill it in with the color. And then v.y will take up the next 4 locations, as you would expect. And that's in blue. And put another border around that. And then v.z is going to take up the last byte. And let's color. Okay, I think I chose a different color every single time. But they're close enough. There we go. Okay. So why do you think the last one is slow but frugal? Because every single time the computer accesses memory, it wants to access at boundaries of 4 bytes. Okay? So let's say this byte is a 4-byte boundary, and you want to access v.y. So it will need 2 memory access. The first memory access will take these 4 bytes, of which 3 bytes are what you want, but not the entire thing, right? So we'll need another access to access these 4 bytes in order to read in a 32-bit integer. So with a 32-bit architecture and a 32-bit data bus, it will need 2 memory clock cycles to read in a 32-bit integer, which is twice as slow compared to this approach here, because it is already 4 bytes aligned. Yep.
Can't it directly address that start of v.y though?
You can, well, because the processor itself is byte addressable. So from the software perspective, yes, you can start at location to start here. But because the memory bus, because of the way the memory bus is organized, every single time you get something, it's actually grabbing 32 bits at a time. And the actual address you can specify on the address bus can only be multiples of 4.
So it doesn't address every byte in the RAM.
From the software perspective, it is byte addressable, but from the hardware implementation perspective, it is not byte addressable. It is only word addressable. In this case, one word is 32-bit wide. So that's why in terms of execution time, the last method, slow but frugal, is slow, because every time you want to access a 32-bit thing, it will take 2 memory clock cycles instead of 1.
For some reason I thought that you could access any individual byte in the hardware.
Yes, but it's an illusion because okay, let's say it's trying to grab v.z. Okay, so let's say you're trying to grab this byte. This is 4 bytes. This is another 4 bytes. So that means the processor will actually access the location corresponding to column F, G, H, and I. And in terms of processor implementation, it will single out the 1 byte here and say, okay, here's the byte that you asked, by tossing away the other 3. Do you see what's happening here?
I just thought it could access any byte anywhere in RAM, not just word size, like byte size.
From the software perspective, it's an illusion.
From the hardware perspective, I thought it
From the hardware perspective, it is always addressing the natural word size of the architecture. So with a native 64-bit architecture, the data bus is going to be 64-bit wide, which means you're always reading 8 bytes at a time into the processor. Now you can say, I want to single out just this byte here. So from the software perspective, you're only accessing 1 char, but from the hardware perspective, it's grabbing all 8 bytes at the same time.
Okay.
Now if you're reading an array, like an array of char, most likely those 8 bytes are going to be cached. So that means reading the consecutive bytes is not going to cause a whole lot of operations. But when you're dealing with dynamically allocated memory and you're accessing things that are out of alignment, that can cost you a bit of time.
What about a 32-bit operating system running on a 64-bit architecture? Would it be slower because of this, or can the Intel processors switch to 32-bit?
It wouldn't be slower because because a lot of stuff is actually done by caching. So the cache is actually doing a lot of buffering. When you read from a certain location, it's not really just one single location. It's really the location a few bytes after that. It depends on how the cache is managed. In other words, the cache manager probably needs a mechanism to find out, okay, am I accessing this location frequently? If so, put in the cache. If not, don't even bother to cache it. So that part is probably proprietary to the Intel implementation. Okay, if you're in the CCMI program, the mentoring program of Intel, you can go ask the Intel employee or engineer and say, okay, so how is the cache implemented Is it always caching by default and then throw away stuff that is not accessed frequently? Or does it have an internal mechanism to track which locations are accessed frequently and then only cache those locations? I don't have the answer.
Again, I'll ask.
And there are multiple levels of caches too. Yep.
How does the processor isolate the byte that it wants from unaligned memory? Does it use the ALU to do that?
That is a good question. The data path coming in is really wide. So in order to single out the byte that you need, some kind of mechanism inside the processor has to do the shifting and just locate the portion that you need. And it has to stitch things too, because like in this case, when you're accessing Y, okay, so let's say you're using Y, you need to stitch the results of two memory access into one single thing before you can process it. So internal to the processor, it has a stitching mechanism which also will serve to isolate individual bytes. So it can merge two memory access into one single thing. It can also single out 1 byte or 2 bytes from a word.
And I'm guessing they designed that to be more efficient than using the ALU. Do they design that to be more efficient?
I don't think it's inside the ALU that they do that. It's probably outside of the ALU. They have some kind of alignment slash stitching mechanism to handle that.
Specific components of an ALU?
Say again?
You might use specific components of an ALU, but in a
I
really
don't
efficient
think
way.
so, because the stitching part has nothing to do with arithmetic or logical operations.
It wouldn't.
So it would be external to the ALU. So the stitching would be done prior to feeding that data into the ALU.
But in order to get a piece of information to be a compilation of two different pieces of information, when you just add them, you do some arithmetic.
So it has a dedicated circuitry to do that part.
Yeah.
Yep. So in other words, it must have some unnamed register that is unknown to software that is basically serving as the stitching mechanism. The first memory access, it has some kind of mux to shift, which byte that you're reading from the memory bus to load into which part of that stitching register. So there will be some kind of cross, mechanism to do that.
So the frugal way is really inefficient.
The frugal way is extremely inefficient, correct? But it is frugal, so if you need to save memory, that's the way you do it.
Is this different ways to allocate memory? Is that what we're looking at?
Yes, the compiler has options to do that. You can actually supply an option to the GCC compiler to optimize for space or optimize for speed.
And so all it is when you're compiling the program, how long it takes.
You're sacrificing execution time for memory
So
efficiency.
when you actually execute the program, if it's efficient, it's going to take longer.
Yes. Yep. Exactly.
So that's why, I'm just thinking Minecraft is extremely resource heavy because it's probably programmed to be frugal.
Well, Minecraft is really inefficient to begin with because it's a Java program.
Right.
So it has to go through the Java virtual machine to begin with. So everything is a little bit slower just because of that.
Yeah, but even with hardware acceleration and things like that, I've had to go in and change RAM allocation with the program itself in order for it to go faster.
Right. Well, that part has to do with how Java deals with dynamic memory allocation because you don't free, right? So there's no way to put freed memory back into the pool so that can be reused right away. So the default behavior of a Java virtual machine regarding dynamic memory allocation is if you don't specify, it will just continue to chew up space in the heap until, quote unquote, you run out of space. Okay, now what that time might be, it's up to the Java virtual machine to decide. So when it does run out, so let's say you only need to use half a gig of RAM for dynamically allocated stuff, but you have a lot of RAM space on your computer. So the Java virtual machine may decide not to do any garbage collection until you have used up 4 gigs of RAM. So out of 4 gigs of RAM, you're only really using half a gig. The other stuff is really deallocated. So now you have to go through a very long, lengthy process to do garbage collection. So during the time you're doing garbage collection, unless you have a very special real-time implementation of the Java virtual machine, you cannot do a single thing. It will just be like garbage collecting, garbage collecting. So you will see, so your Minecraft experience won't be very pleasant, when it's doing garbage collection.
It's not very, the game is very poorly optimized.
It's because of Java.
But it's highly moddable because of the use of Java.
Yeah,
That's true.
That's the one good side.
Yeah, because you can, once you know the hooks to do things, you can write your own classes, then you can do a whole bunch of stuff, pretty easily.
I'll try that in C++.
Right, C++ is extremely hard to do. Okay, now this is the other thing that you might need to kind of pay attention to, is if you have some object code that is compiled using the fast and wasteful way, fast but wasteful, and then you have other object code compiled using exactly the same source file, but the compiler flags are changed to do the slow but frugal, then you will have massive problems. Because a part of the program will say, oh, I understand the structure like this, it looks like this, okay, not a problem, right? And then the other program or the other object code will look at it and go like, no, I think it looks like this. Now this is not a very good example because there's no way I can actually export this unless I do any type of funky typecasting. Okay, nobody actually needs to know what is inside V, so it's going to be self-consistent for the most part because you cannot even do this outside of the same source file. Okay, V can be a global variable, but it will still be compiled using the same options unless you use Pragma to change that option halfway through compiling the same file, which is awfully a bad idea. Because with Pragma, #Pragma, you can change the options of the compiler. You can change how it compiles midway through the compilation of a single file.
Why would you do
Just so that half the program can use memory optimization and the other half can use execution optimization. Now I'm not making this up, okay? So you can look into GCC options to optimize struct, okay?
Does it also let you customize the memory alignment?
I think so. I'm just looking for the memory optimization part. Probably look for struct with a space after that. Nope. Maybe it's alignment. For alignment. Function alignment. Branch target. That's just for function. Space, size.
Maybe that's too quick for the question.
Say again?
This one? Maybe that'll have answers.
Okay, so it's packed versus align.
Hey, Professor,
Mm-hmm.
is there a limit of how many times you can go through a loop in C++?
Like a definite limit before it says, oh, you've got an infinite loop, because it thinks you've got infinite loop, but you don't.
No?
For the purpose of optimization or?
For the purpose of writing.
Let's say I have a long, it's a huge number that I
Yeah.
want to loop through one by one by one.
Yeah.
Is there a point where the computer will just tell you, hey, this is an infinite loop?
No.
You know,
No, you will keep doing it.
all right then.
Yeah, the C code compiles still pretty faithfully into what it is supposed to be unless you turn on optimization. When you asked that question, I was thinking, are you talking about unfolding a loop? Because there's an optimization technique called unfolding. So instead of using a loop where you have a check, a conditional statement, and then a unconditional branch back to the beginning, the compiler, if you can recognize that you're just doing something 5 times, it can do the unfold method, which means it's just replicating the content of the loop 5 times. Boom, 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 boom. So you don't have any conditional, you don't have branches, because branches are very bad for pipelining. Pipelining is a technique that people use in the processor where you can be on one stage of executing one instruction, on the second stage of executing another instruction, on the third stage of executing yet another instruction. So you're pipelining to optimize how much you can do on a per clock basis. Think of the assembly line, okay? Think of we are on an assembly line, and without pipelining, okay, I am just doing the assembly, but so let's say we have 4 people doing assembly in an assembly line. So without pipelining, it's basically saying, okay, only one person can do assembling, can assemble that object at any particular time. So I will do the entire assembly from start to finish, and then the next person will start and do the entire assembly from start to finish. But while the second person is doing it, I'm not gonna do anything. Okay, so it's not a good use of resources. So a typical assembly line is like, okay, we have 4 people. Okay, let's say we are assembling Furbies. Okay, so the first person will be doing, okay, I'm going to put the circuitry, into the packaging and whatnot. The second person will put in, the ears, the eyes, and whatnot, and then the third person will stitch everything up, and then the fourth person will put it into a box, put a label on it, and stuff like that. Okay, so with pipelining, all of these things are happening at exactly the same time. So the throughput of the pipeline is high. But if you do not use pipelining, it means there's only one person doing all 4 tasks, okay, sequential. So one person has to do the circuit board, put it into the body, stitch it up, put it into the box, and then start from the beginning. Okay, so when you have branches, it is not good for pipelining, especially conditional branches. Because pipelining means you need to know what the next thing needs to do. With branching, you don't know exactly, because you can say, well, sometimes we'll end up over there, which we increment a register, and sometimes we just continue execution where we compare the registers. Okay? So it cannot predict what you're supposed to do. So depending on the architecture, some architectures will actually do both at the same time, and then by the time you know the flag, it will just throw away the result of one branch. That's one way to optimize so that you can get rid of that problem of branching in pipeline. I'm not really 100% sure what the Intel architecture would do upon branching, but the bottom line is branching is bad, and with every type of usual loop you have branching, you have conditional branching. So by unfolding a loop, let's say you're doing x++ 5 times, so instead of having to check every single time, you just say add 1, add 1, add 1, add 1, add 1. You do not have any conditional branches anymore. So it would pipeline a lot better, and it will execute a lot faster. It doesn't work very well when your loop is complex and has its own conditional statements and whatnot. Then the gain is not really significant. So the compiler would usually sometimes do that type of optimization.
You also don't usually have a lot of definite loops. You don't usually have a lot of definite loops, so it's not
that is true. That is true. But if you do, then but the compiler can potentially do some work to do that. You can look into that by looking into GCC unfold. Unroll. Okay. Fun roll.
Looks like it worked, but if I try to do another.
Now, when you do all these optimization, you are only making suggestions to the compiler. By the way, the compiler can say, "I understand that you want to do optimization, but I choose not to." Just like inlines. Inline is not guaranteed. If you say inline la 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 la, the compiler will look at the function definition and go like, "Yeah, we can do this." Or the compiler can say, "Nah, bad idea. Not going to do the inline."
Are register variable types even less guaranteed? Can't you have a register variable type?
Yes, that's a suggestion. You're basically saying that you're basically telling the compiler and say, "I'm a smart ass programmer. Let me tell you that this register or this particular variable, it'll be beneficial for the execution time to store this in the register. You're suggesting to the compiler that it will be beneficial. But the compiler can go through this code, do the analysis, or based on the limitation of the architecture, and you say we don't have that many registers, so the compiler can crank out normal code despite you saying that this should be a register. It's only a suggestion.
I think that thing pretty much is ignored by most compilers nowadays.
You mean register?
Yeah.
Register is, depending on the implementation, depending on the actual meaning of register. So the question is, does register preclude or exclude auto at the same time? Now, if register is on its own and just say that, okay, this is a quote unquote register variable, and it says, okay, register variables are not auto, then it can be very bad. It can break code left and right. Because anything that has reentrancy issues, like you have a string copy, right? So you have a string copy, you have a multi-threaded program. One program is already in string copy. The kernel cuts in and go like, okay, this thread needs to give up control, let's resume the other thread. The other thread then calls string copy. If a variable in string copy is in a register and is not considered auto, then they can collide and one thread can overwrite the register variable without the other one knowing about it. So that can be very bad.
Just add a mutex log.
Then?
Just add a mutex log.
But if you do a mutex, that means the other one cannot even start until this one is finished. And string copy is not something that should be locked out. It's not, because it's not a common resource, right? Unless you're string copying to the same destination, yes, then you should lock it out. But if you're just string copying something that is completely independent, you should not impose dependency in that case. Which can also lead to starvation and all kinds of fun stuff. All right, so I think we got a little bit out of scope today. But nonetheless, we did finish what we set out to do, so which is a good thing. I am going to upload the recursion program to the shared folder. So for those of you who want to kind of test run it and actually see what is happening to the registers, the memory locations and whatnot, I think it is very beneficial to at least go through the trace once, just to see how it does things. So I'm going to upload that to the shared folder, which is here. Okay, there we go. Upload the file, and it's in my folder. I'm going to upload all.rom as well, just so that you guys can use all.rom. It has all the instructions implemented up to this point. And then we have the other one, which is the RAM file. Recursion, there we go. So those two files are now on the Google Drive. So you guys can do exactly what I did in class. And I would go through this at least once, at least with the tricky part, like, how do you actually make the call and how the return happens. I mean, those two parts are, I think, particularly important. Are we good so far?
Yeah.
Okay, so I'm inspired now to make my own assembler because I'm writing so much code and I know we only have 2 class sessions left.
Yep.
If I use the lab time, we'll make it 4. So that is 4 times 80, which is 320 minutes. That's still a lot of minutes. I think an assembler will still be beneficial for those 320 minutes.
Weekend project, right? You can do this over the weekend?
Maybe today. Well, I have to grade your midterm too.
Does that mean we're going to get our grades by Tuesday?
Yes. Yes, you will get a grade by Tuesday. I just need to interleave the fun stuff with the not so fun stuff. Yeah. Procrastination is like, I want to code. No, I never do grade. I want to code. I never grade.
That was me last semester. It's like, I want to code. Oh, I got all the general ed stuff.
Are you regretting giving us hard to grade problems on the test?
No, it's not that hard to grade. It's just that I need to spend the time. I really enjoy grading these type of questions because I can see how people think. by looking at their mistakes or not. Okay, I can tell how people think, which is good because I need to know that. It is still very long as a process. And I personally really like to code. That to me is like a hobby. It's like I need to take some time off. Okay, I'm gonna go back to the program some more. So, but I will write my assembler because it's gonna be useful, and I will see if I can write it in a spreadsheet.
Oh, why?
Just because I can.
You can't self-learn something you don't even know exists.
It's faster if you do it in C.
360, bro.
I can do it in C, which is also portable. So I'll figure out what to do with that. The best programming language to do compilers, something like this, is actually a scripting language. Something like Perl or Python would be really great because they can do regular expressions. So that makes it a lot easier to extract portions of a particular opcode, and also do syntax check and all kinds of stuff.
Instead of making your own ugly parser.
Instead of making my own ugly parser, if I have to make a parser, I'm not going to use infix notation. I'm going to use a postfix notation using RPN.
What's that?
Oh, okay. So RPN.
Oh, RPN?
RPN, reversed Polish notation.
I still teach myself stuff all the time. But like,
Okay, so
when you do that, there's gaps in knowledge.
y plus x times z, the whole thing divided by,
Okay, like you teach
I don't
yourself
know,
Java.
6
Yeah. I
plus
probably know more Java than the class.
x
Oh, I know.
squared. Okay, so let's say this is what you want to compute.
It's
Okay,
gaps.
this is using infix notation, which means the operation is specified between the values that you need to operate on, right? So to do this in a prefix notation, you would say, y, okay, and then you say x, z, multiply, because the multiplication is basically a pop 2 and then push 1 kind of thing. So you maintain a stack of the values. So every time you just specify a value, you're pushing it onto the stack. So the multiplication will pop 2 things, do the multiplication, and then push the product back on the stack. Okay, so now we can do the plus, and then we do the other part, which is a 6, and then an x, and then a squared. That's an operation. And then we do the plus after this, and then we would do the divide. So that would be the postfix notation to do exactly that.
So what's RPN?
RPN is just that. It's reversed Polish notation. Now, why it is Polish, I do not know. Probably a mathematician, Polish mathematician, did that first.
Yeah, Ross went over it.
Was it a Polish guy who did it?
Oh yeah, those Polish dudes. That's what Subsavary always says.
Those Polish dudes?
And he like anytime we learn some new algorithm or something, he's like probably some Polish dude.
All Russian. So, but the nice thing about reverse Polish notation is extremely easy to parse. You need to manually maintain your own value stack, but it's very easy to deal with because you don't have to deal with nesting of parentheses. I mean, do you know how hard it is to deal with parentheses? No parentheses whatsoever. It's either a number or an operator.
We did it.
Number, separator, or operator. I can deal with that. Yep.
We put it from regular notation to postfix or prefix, and then from prefix, and then we calculated it in Subsavary's class, 430.
Everything can be seen as a tree.
Yeah.
So infix notation is basically saying the operator is the root, and you care about that. So it's a in terms of traversal, it's called a infix traversal. You traverse one tree and then you do the operator and then you traverse the other tree. That's infix notation. If you do a dec first, then it becomes a postfix notation. If you do a if you specify the operator first and then you specify the trees under the operator, then it's a prefix notation. So everything can be represented as a tree, but this is so much easier to parse. All right, so I think we have gone past the scope of this class sufficiently today. I feel accomplished. My med did not go to waste.
Or if you use an existing